So the example problem number 79. Calculate the freezing point and melting point. We're just going to do the freezing point. So calculate the freezing point of a solution containing 10 grams of naphthalene, which is C10H8, in 100 milliliters of benzene, and it gives you the density of benzene is 0.877 grams per cubic centimeter, or grams per milliliter. All right, benzene C6H6, we don't really need to know that, though, for this problem. All right, so calculate the freezing point. The one thing you do have to look up is KF, and KF for benzene is 5.12 degrees Celsius per mole. Right, and our formula is delta T equals KF times M times I. Well, what's I, the Van Hoff factor here? Well, naphthalene, molecule, hydrocarbon, I is 1. Okay, so now we need molality. And so for my molality would be moles of C10H8 all over kilograms of benzene. And what do I have? I have 10 grams of C10H8, and we have 100 milliliters of benzene. So what do we do? Well, let's convert. Well, grams to moles. I think we can do that. We know that there's 10 carbons, so that's 120 and 8. So 128.18 grams of C10H8 is 1 mole. C10H8. Okay, then, so now we're in moles. That's good. We know that for every milliliter of benzene, we're writing the word out, benzene, there is 0.877 grams of benzene. Right? Because 1 milliliter by definition is 1 centimeter cubed. And we know that. And then 1,000 grams of benzene, 1 kilogram. Okay. So if we do this, the molality of benzene looks like it's going to be 0.889. I'm sorry, the molality of naphthalene in benzene. Okay, so delta T was KF times M. I is 1. So delta T equals 5.12 degrees Celsius per mole times 0.889 mole times 1 for the Van Hoff factor. I don't want red. 1. So it looks like delta T then happens to be 4.55 degrees. Alright, so that's delta T. Very good. We're looking for the freezing point. So we have to look up the freezing point of benzene. And it's in the book right where the same KF value is in this book. Alright, and we look it up, it's 5.5 degrees Celsius is the normal freezing point. Delta T here would be going down 4.55 degrees. So my new freezing point would be 0.95 degrees, which happens to be 1.0 degrees Celsius, because I can't keep that number. Alright, so that would be how we do a delta T KMI formula, right, with the freezing point depression. The boiling point, then you just do this. It's the same modality, the different constant, and the boiling point goes up.